Hello friends, today we are going to see lead code medium problem to count the number of islands on the given grid. You are provided with an m by n 2D binary grid which has a value 1 and 0. 1 represents the land and 0 represents the water. So let's see this example. In this grid, the ones are connected by up cell, down cell, left cell or right cell. So for this one is connected with this one and this one. Further, this one is connected with this one and this one. Okay, and this one is connected with this one. But the ones are not connected diagonally, means this one cannot form a connection with this one. Okay, so on this grid, you will see that all ones are connected, so the number of island is only one. Now let's take a look at this second example. In this case, this one is connected with this one and this one. Similarly, this one is connected with this one, but there is no way to reach to this one. So these four ones form one island, and this single one form another island, and these two ones form third island. Okay, so the output of this example should be three island on this grid. Now let's see the approach which we'll be using to solve this problem. We'll be using depth first search. So what should be our algorithm? Initially, we will check if the grid is empty or it has 0 rows. In that case, we will return the number of island as 0. If the grid is provided to us, in that case, we will iterate the entire grid using for within for loop. So we will check if the current cell value is 1. If the current cell value is 1, then we got the first one in that island. In that case, we will increment the number of island counter. So initially the number of island counter is 0. Now once we reach the first one, we will call Dfs function on it. Now what this Dfs function will do, let's see the Dfs function logic. Now we'll check if the current cell is a valid cell, means it is present within the grid. If it is within the grid and its value is already 0, in this case you should simply return. If it is not, then you should go to else part. In else part, when you are coming to else part, it means the value is not 0, the value is 1. So in this case you will make this 1 as 0, and once you make this 1 as 0, then you have to call DFS on all 4 neighboring cell. So you should call DFS on it left cell, right cell, up cell and down cell. Okay, so this DFS function, basically what it is doing, it is making all its neighboring 1 to 0. Means this DFS function is going to make that entire island, all one on that entire island, to 0. Okay, and once this function DFS function do it, it will go back to our for within for loop which iterate the grid. Okay, and then it will search for our next one, and then again it will call increase the number of island, and it will call DFS on that cell. Again the DFS will make all those ones to 0, and it will go back to for within for. Let's see the code for it. Okay, so here we are going to check the grid is null or the grid, the number of rows in the grid are 0. In this case, we'll simply return the number of island to 0. Otherwise, you should declare the number of islands to 0. Now iterate the 2D grid using for within for. So I'm going to declare a for outer for loop, which is dot length I plus plus. And in this for loop we are going to write one more for loop for a j, and in this for loop what you are going to do is we are going to check if the grid value is 1. In that case you will increment the value of number of island and you will call dfs. To this dfs function we are going to pass the grid and the current cell coordinates, and after the for loop you are simply going to return the number of islands. Now let's write the dfs function. So I'll write a private function which will not return anything, and this is our character grid. Now we have the coordinate in I and j. First we have to check if the current cell is valid or not. For that, how you're going to check is if the current cell is within the grid, means if I is less than 0 or I is greater than equal to number of rows in the grid, or j is less than 0 or j is greater than equal to grid of I dot length, or check if the grid's current cell value is already 0. So in this case you have to simply return. If it is not, means we have the grid cell, valid grid cell, and the current value is 1. In that case you have to make the current cell value to be 0, and then you have to call dfs on it, left, right, up and down cell. So how you are going to call it? Grid I plus 1 comma j, and I'll just copy this, I minus j, sorry, I minus 1 and j, and here for left and right cell j minus 1, and this will be j plus 1. So this dfs function will make all 1 on that island to 0. Now let's submit this solution and let's see if it passed the basic test case. Yes, it's passing the basic test case. Now let's submit the solution, and it has cleared all the test cases for this problem. Okay guys, I hope you understood this problem. This is very important problem. It's a template question. If you know this algorithm, then you can solve many problems on the similar pattern. Can you guess the time complexity and space complexity for this algorithm? The time complexity for this algorithm is m by n, where m is the number of row and n is number of column, because we are iterating the entire grid. Now what can be the space complexity? We are not using any extra space, right? But when you call dfs, it create a stack. So what is the maximum stack size you can create? The maximum stack size will also be m by n in the worst case. So the space complexity also is order of m by n. If you like this video, please do subscribe to my channel. Thank you.